Hello, mathematicians, puzzlers, and other curious people. I've got a minute, so I'm going to make a little video. We're here today to talk about everybody's favorite thing, fractions. What? Do I hear some boos and hisses? Oh well, we'll be all right. But we're not just talking about fractions today. We're jumping straight past fraction multiplication and fraction addition. We're going to go ahead and talk about fraction division. Now, spoilers, we'll need a little bit of the rest of those along the way, but that's okay. We'll pick them up as they go along. So here's what we're dealing with right here. So we are thinking about how we can deal with problems such as, say, 1/3 divided by 1/2. Now, I'm going to just put that in a thought bubble and come back to it because we're going to mess with some stuff first. So if we were multiplying, it'd be pretty straightforward. So like if we had 3/4 times 2/3. Well, we know that we can sketch that out and say, okay, here's 3/4 and 2/3. Well, what do we have there? Well, let's get some color coding up in here because everything's better if we color code it, right? So we're really interested in those pieces. So we've got 6 pieces in all out of 7, 8, 9, 10, 11, 12 pieces. So 6 out of the 12 pieces in all, which, yeah, we can simplify to 1/2, but this right here is good enough for a lot of problem-solving purposes. And we notice that we've got 3 out of our 4 pieces getting multiplied by 2 out of our 3 pieces. So multiplying lets us just go straight across to come up with the 2 numbers that are in there. Now, yeah, spoilers, you might also have noticed that since we're going to have 3 times 2 getting divided by 4 times 3, we can pre-simplify that. We can rewrite the 4 as 2 times 2 and pre-simplify that and get to 1/2 that way. And if you're comfortable with that, that's great. All we need from multiplying fractions right now is to know that we can multiply straight across, and that works. So if we had 6/12 getting divided by 3/4, well, we know division is the opposite of multiplication. If we had 6/12 getting divided by 3/4, we should expect that answer to be 2/3. Well, that sure makes sense. And again, we always want things to make sense. Because if it doesn't make sense, it's not really math because it's not really noticing patterns. But then we come back to this here. We can't just divide straight across because we would get something like, well, 1 divided by 1, that's not so bad. 3 divided by 2. Well, let's see. That'll go once. That uses up 2 and leaves 1. Well, we don't want to have 1/1 remainder 1. Or, let's see. Uh, 1/1.5 is less bad than the other, but we'd really like it to be just 2 straightforward, simple, whole numbers. So clearly just dividing straight across isn't enough. So we need to make our 2 fractions compatible for division. Well, what did we do to 2 fractions to make them compatible for, say, addition or subtraction? Well, let's think that through a bit. So if we were going to do 1/2 plus 1/4. Well, we know that we don't just go across and say that that's 2/6. And one reason we know we don't do that is, okay, I'll stop there. Well, if we had 1/2 and then we added on to it by 1/4, Well, that should give us something that comes up to here. But 2/6 would only come up to there. So again, we always want what we're doing to make some kind of sense as far as what the numbers really mean. We're not just trying to manipulate digits within a problem. We want adding to mean making more of something, as long as we're dealing with positive numbers in the first place, which I'm just forgetting for purposes of this lesson that negative numbers are a thing. Of course, we could have negative fractions later on, but I'm just not going to touch them today. Okay, so we need to make these numbers compatible for dividing across. Well, how can we do that? And again, how can we make these numbers compatible for addition? Well, we can say, okay, let's split these things down a little bit better. So that 1/2, let's write it now as 2/4. And when we have the same denominator, that makes it pretty easy to see that 2/4 and 1 more fourth comes out the same as 3/4. If you have 2 quarters in your pocket and then you pick up a quarter off the floor, well, then you have 3/4. So having the same denominator makes these numbers compatible for addition. Let's think about that over here. So let's think about a common denominator here. So just like we would do for addition and subtraction, we would say, okay, we've got thirds and halves. So we need a way we can nicely draw both of those. And I found out that I can nicely draw both of those if I use 6 pieces. 1/3 and 1/2. So if I cut those down to 6 pieces, what I've really got here is 2/6 divided by 3/6. Well, if I divide that across, now 6 divided by 6 just goes awesome. That's just 1 whole. Now 2 divided by 3 is much less awesome. So I'm just going to jot that down in here as 2 divided by 3 for a minute. But there's another way we can write division. Now, depending on what kinds of calculators you've used, you've probably noticed that on some calculators, or for coding purposes, division might be written with this, which looks like a fraction bar because it is a fraction bar. Remember, a fraction is just a division problem in disguise. So another way we could write 2 divided by 3 is just 2/3. And remember, when you put a number over 1, well, it's just itself. So our final answer there is 2/3. So it turns out that 1/3 of 1/2 is 2/3. Hang on, that didn't, okay, 1/3, oh, sorry, 1/3 divided by 1/2. So my goof up, I'm looking at it sideways. Okay, so 1/3, yeah, that'd be multiplication. I welcome your emails. Okay, so all mathematicians say things sideways now and then. So let's get this straightened out. So 1/3 divided by 1/2. So if we take a third and try to divide it up into groups of size 1/2. Well, we don't even have one entire group here. We have like 2/3 of a group. So 1/3 is 2/3 of 1/2. So 1/2 makes 2/3 of a group of size 1/2. So that is a way you can deal with dividing fractions. Okay, so I'm just going to clear this real quick and let's try this out a couple more times. And I'm just going to make up numbers wildly. So let's see, 5/12 divided by 2/3. Okay, well, I noticed that 12 and 3 are like almost compatible. So like the 5/12 can stay the same. The 2/3, I'll just multiply both parts of that by 4, so I'll have 8/12. So then I'll have 5/8 of a whole, which is really just 5/8. Let's see, one more. Let's get an improper fraction into this mix. So let's see, 7/3 divided by, what's a good one? Let's do divided by 1/2. So let's see, again, making those compatible. Well, thirds and halves are both compatible with sixths. Okay, my first fraction, the thirds got split in half, or got split each down into 2 to make sixths. So we'd have 14 of them, and over here we'd have 3/6 to be 1/2. Well, that'll be 14/3 of a whole. So that's the same as 14/3. Now, if you're really paying attention, you might have noticed that if we doubled 7/3, if we doubled 7/3, 1, 2, 3, 4, 5, 6, 7, if we doubled 7/3, so 1, 2, 3, 4, 5, 6, 7, we'd have 3, 6, 9, 12, 14/3. So dividing by 1/2 seems to do the same thing as doubling. Now this gives us a trick that we can use to divide fractions even more quickly. So 7/3 divided by 1/2 is the same as 7/3 times 2. If we put the 2 over 1, we can easily see we would go straight across, and that'd be 14/3. So it turns out that dividing by a fraction is the same as multiplying by its reciprocal. So we can do this problem that we did before on the other side of the board the same way. So I'm just going to scoot this aside. So another way we can deal with fraction division is we can say, okay, 5/12 times 3/2. Well, this doesn't seem very much the same because we've got 15/24. But I'm going to notice that 15 is just 5 times 3, and 24 is just 8 times 3. So 5/8 is really the same. We could draw 5/8. There's 5/8. And then if we cut them each down by 3, I need to fill some of those eighths in better for this to show correctly. So if we cut them each down into 3, we'd have 24 pieces in all, and 15 of them would be filled in. So 5/8 really is the same as 15/24. The simplified version is often more convenient because it uses smaller numbers and it's easier to imagine. So why do both of these ways work? Well, it has to do with the basic nature of division, but we can see with some number patterns why it could work. So I hope nobody is allergic to algebra today, because I'm going to be throwing some variables into the mix. If you're allergic to algebra, you might want to run and get some tissues or an antihistamine. Or if it's a skin allergy, maybe some soothing cream. So here's our variables, if I can choose the right writing tool. Here's our variables for real this time. If we've got A beefs divided by C deeths, And because beefs and deefs are a little inconvenient to say, we'll often just say A over B divided by C over D. It's just easier to say it that way. Well, if we're going to try and make those compatible for addition, subtraction, or as it turns out, division, common denominators help. Well, we don't know what B and D are, so there might be another common denominator sooner. Like if they're 2 and 4, 4 could still work. Or let's see, if they're, what's a good example? If they are, say, 15 and 12, then we might not need to multiply them both together to get, what would that even be? I'm losing my mental math abilities because I'm in front of a computer. 15 times 12 would be 180, but 60 would work. But we know that B times D will be some common denominator, even if it's not the lowest common denominator. Okay, well, what did we scale this fraction up by to get to that one? Well, we multiplied the B by the D, so we need to do the same to the A. And the same thing over here. We multiplied the D by the B, so we need to do the same to the C. So we'll have E, C there. Okay, pretty straightforward so far as it goes. Well, now we know that BD divided by BD, maybe that's 12 divided by 12, 36 divided by 36, 180 divided by 180. We know that that's going to be 1. And then we'll just have AD over BC. And since we don't like layer cake fractions, but it's just over 1 anyway, we'll just jailbreak it. And there we have it. But that's just what we started with. And then a flipped version of what we had for our second one. So that's AB times the reciprocal of CD. So that is why you can either, when you're trying to divide fractions, you can either get a common denominator, or you can use the strategy of flipping the second fraction and multiplying. Now, I want to make sure you all notice really carefully that the first fraction does not get flipped. That's very important. Now, if which fraction gets flipped falls out of your head as you're trying to do a fraction division problem, that's okay. Just get a common denominator and divide across and it'll be okay. And then look really hard at that and notice the pattern, and you'll be able to see, okay, the first stays the same, the second gets flipped. But if you remember that the second gets flipped and then it's treated as a multiplication problem, that's a nice, fast, zippy way to deal with fraction divisions. I'm Avrila at Math with Avrila, and I will calc you later.